Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal super senses. You won't believe what's possible. What we see above the ground is only a small part of the natural world. A busy, complex web of life lies just beneath our feet. Fossorial animals are well adapted to life underground. They live in burrows, tunnels, and mounds, using the earth or whatever substrate they live in to build their homes, find their food and friends, and stay safe from enemies. In this episode of Animal Super Senses, we find out more about the animals that have their feet firmly planted on or under the ground, and find out how their senses are tuned to survive. For animals that live underground, adaptations for digging deep come with the territory. That includes strong limbs, claws to dig with, and a keen sense of touch. The wombat is the largest burrowing mammal, found in the temperate forest of southeastern Australia. They have stocky, powerful limbs, short necks, and broad, flattened skulls, perfect for pushing through the soil. Their forepaws are used for excavation. They can remove just about any obstacle with their incisors. To expand the sides and roof of a tunnel, wombats twist the upper body and perform barrel rolls. Their front end is backed up by an impenetrable posterior. Wombats have what is called a dermal shield on their rear, a plate of bone, muscle, and cartilage that can help defend their home from intruders. They can seal the entrance with their tough bums, or squeeze under the invader and slam them against the tunnel roof. To avoid the heat of the day, this marsupial stays cool in its burrow. The wombat comes out at night to feed on grass and the roots and bulbs of plants. They are able to pick up the most tender shoots because of a split upper lip. And to cope with their fibrous diet, they have open-rooted teeth that are continuously growing, a feature unique among marsupials. A sense of touch is highly advanced in those that have a habit of living like a hobbit, and the wombat is no exception. Their cheeks, jaws, and wrists are covered in vibrissae, whiskers that are specially designed for tactile sensing. Many animals that live the subterranean life have a need to be in close contact with their surroundings. It's a sense known as positive thigmotaxis. And although wombat senses haven't been studied too closely, it's likely they have this need to be in touch with tight places too. In the deserts of Central Australia, there are other creatures, many times smaller than the wombat, who also make their home underground. To shelter from the searing heat, rodents escape by burrowing deep into the cracks formed in the gibber, or stone-covered plains. Feeding mostly on seeds during the nighttime, they are perfectly adapted to the arid climate. They get all their fluids from their food. Gibber rodents live in small colonies, keeping in contact with burrow mates using a variety of calls, including squeals, whistles, chirps, and chatters. It's thought that their hearing is best at ultrasonic frequencies, perhaps an adaptation to avoid predators who may be listening above the ground. This rodent is not alone. Its subterranean shelter could be its undoing. Another creature is searching for sanctuary from the sun's heat and looking for a tasty meal. The inland taipan dwells in the cracks and crevices of the dry, rocky plains. And lucky for them, their favorite food lives in the same place. Cornering the rodent in its burrow, the taipan strikes with deadly poise. Injecting a lethal cocktail of paralyzing poisons. Its highly toxic venom is considered to be the most potent of any land.
I think that's an interesting thing.
This one piece will make 52 layers.
Watch on mobile devices or the big screen. All for free. No subscription required.
Snake in the world. The venom acts so quickly, the victim has little time to fight back. Food is scarce in the desert, and the snake must make use of every sense to find its prey. Smell tasting is the most important tool for sensing food. The forked tongue flicks rapidly, tasting the air for prey odors. This chemical information is then passed to the Jacobson's organ in the roof of the mouth, and then back to the brain for processing. Taipans can also detect their prey by sensing movement. They can hear by picking up vibrations along the ground. These travel through to the inner ear by means of a chain of bones in the lower jaw. Using its senses in this underground lair, the snake is a supremely adapted killer. Searching for prey certainly tests the sensory limits of animals. But when your food is minuscule and hidden, it really does need super senses to find them. The short-beaked echidna has a specialized diet. It only eats ants and termites found deep under mounds and logs. To get to the insect nibbles, the echidna uses its powerful, stout limbs to dig into the soil and rip open rotten wood. The front feet have 5 flattened claws, and the hind feet point backwards, helping the animal to push the soil away when burrowing. But it is the echidna's nose that is key to its success. Highly tactile, 8 centimeters long and rigid, this fair-sized proboscis helps this spiny anteater forage and poke around for food. The tongue can dart out to a length of 18 centimeters to catch its prey. And with the help of some very sticky saliva, with the consistency of molasses, ants and termites have little chance of escape. The snout is covered with tough, hairless skin containing glands and sensory receptors. Echidnas can detect prey by smell, but they also have an additional sense, found only in a handful of animals on the planet. With the tip of the snout, they are thought to have the ability to sense electricity. Until recently, the platypus and echidna were the only mammals known to use electroreception. Both are monotremes, egg-laying mammals, an ancient order of animals left over as a relic of evolution. The structures responsible for the electric sense in echidnas are sensory mucus glands. It's not fully understood how they use these, but tests have shown they can detect weak electric fields in water. As water is a good conductor of electricity, echidnas may be able to detect moving prey in moist soil. Even with a tough snout, echidnas generally avoid large biting ants for good reason. These nests are usually safe from anteaters. That's because there's a formidable fighter within. Australian bulldog ants are among the biggest and most primitive members of the ant world. They also pack a punch in their venomous sting. Easily recognizable by their huge jaws, bulldog ants use their sizable mandibles to carry food, construct nests, and defend their territory. They are active hunters and ferocious. If an intruder dares to venture near, the colony swarm out and attack within seconds, stinging them repeatedly with their venom. The ant chamber is underground and can extend several meters below the surface. It's here the queen lays her eggs, which hatch into fat, helpless larvae, lavishly tended to by workers. Most ants have poor eyesight, but a few have exceptional vision, and the bulldog ant is one of them. And they need their super sight to keep up with the insatiable appetites of their young siblings. Adults feed mainly on honeydew and nectar, but the larvae are carnivorous. The infants signal their hunger by raising their heads. Worker ants on dinner duty leave the nest and hunt alone, using their large eyes to find prey. Once they find a victim, they immobilize it with a deadly strike and carry it back to the nest. Workers bring dead beetles and bees into the chamber. The larvae attach and feed straight away. In their underground lair, it's important to be in constant contact with nestmates, both adults and young. The ants' antennae are special organs that help them detect chemicals and are also the touch sensor. They are used to identify friends from foe. Such an important sensory tool needs to be kept in top condition, and ants spend a great deal of time preening their antennae. An ant colony is a finely tuned machine with thousands of workers going about their jobs. And it's their super senses that keep this well-organized metropolis ticking along. Bulldog ants prove that being pocket-sized doesn't mean you're powerless. But there's a beast that ants would prefer not to run into: the antlion. It's not an ant, and definitely not a lion, and although it may not be as big as the king of the jungle, it's no less deadly. They are the larval form of a type of lacewing insect, and they are an ant's worst nightmare. Because antlions build death traps for their unsuspecting prey. They live buried in the sand, where the larvae dig funnel-shaped pitfalls with such efficient construction, it would put an architect to shame. The slope is steep enough to guide prey to their mouths, but shallow enough to avoid avalanches. The trap's sides are set at a perfect angle. When prey falls in, it has no way of getting out. Thanks to the unique wave propagation properties of sand, antlions can make use of the sand-borne vibrations to sense when their prey is near. These vibrations are picked up by sensory hairs on the head and antenna. It seems the antlion's senses are perfectly in tune with its sandlocked life. Deep in the Namib Desert of southern Africa is another predator who detects prey from vibrations carried through the sand. These are sit-and-wait huntsman spiders, and this parched earth is their home. The Namib huntsmen live in burrows that extend diagonally into the dunes. At night, they hunt insects, waiting patiently for the telltale signs of dinner as it crosses the spider's domain. Elongated hairs, called trichobothria, line the antenna-like pedipalps and legs. These sensory hairs are stimulated by air currents and low-frequency vibrations. The spider waits until the subtle tremblings of the sand signals its prey is nearby, then darts out to ambush the victim. During the day, dune spiders escape from the heat of the sun by staying underground, only coming out to repair or construct their lair. It's not easy to dig tunnels in the shifting sands, but the spider succeeds by lining the walls with silk. And it's at this point that the spider is at its most vulnerable. Their arch-enemy is a pompilid wasp, a parasite with a predilection for laying its eggs inside the spider's body so the hatchlings have fresh and living meat to feed off. But all is not lost because this particular dune huntsman has a nifty escape plan. If its burrow happens to be on the side of a steep enough sand dune, it takes off and effectively invents the wheel. The spider rolls onto its side, tucks in its legs, and cartwheels down the slope, accelerating to a speed of more than 1 meter per second. That's the equivalent of a car traveling at 300 kilometers per hour. This species is not known as the wheel spider for nothing. Brush turkeys seem to have embraced the idea of modern man, because in this bird's world, it's the male that does the housework and looks after the kids. Male turkeys build large mounds comprised of decomposing vegetation, leaf litter, and soil. The suitor with the best maintained mound gets the girl. Females lay their eggs and then leave, and it's left to the fathers to look after the young. As the decomposing vegetation produces heat, it incubates the eggs. Keeping the right temperature is vital for their offspring's survival. So males check the warmth of the composting by inserting their heads in a hole. To keep a constant 33 degrees Celsius, the turkey removes or adds layers to the mound as needed. They can take the temperature by using highly acute heat sensors inside their upper bill. Without the brush turkey's bill thermometer, the embryos wouldn't develop. It's thanks to their super heat sense that a new generation is born. The senses are the stars on animal supersenses. We've learned digging deep doesn't stop animals from sensing their surroundings. and making the most of what the Earth has to offer. Join us next time on Animal Supersenses to find out more incredible powers of animal perception.
Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever manage to stay on top of the food chain. Animal supersenses. You won't believe what's possible.
Throughout the natural world, individuals interact, and sending and receiving information is vital for survival. Animals use communication to attract mates, ward off predators, defend territory, or trick their prey. And of course, it's the senses that play the key role. Sight, smell, taste, touch, and hearing are all employed to send signals to others, in the hope actions speak louder than words. In this episode of Animal Supersenses, we find out more about the sensory powers used by animals to make messages loud and clear. Sun-baked Africa. Many animals find sanctuary from the heat in rivers and lakes. To keep cool, hippos spend much of their day wallowing in water. Even with their bodies submerged, the hippo can still see, hear, and smell what's going on around it. Their epidermis is thin, with no sweat glands. But they do secrete a red fluid, giving rise to the myth that hippos sweat blood. This secretion contains a sunscreen, an antiseptic, and moistens delicate skin. Large, slow, and rotund, these amphibious giants seem gentle and rather sleepy. Yawning is a major pastime. But looks are deceiving. A large hippo guards his harem of females from sneaky males. If provoked, he will show who is boss. At 2,700 kilos, with formidable canines, the alpha sends a clear message to would-be Romeos. That's no sleepy yawn. It's a threat posture. Their 50-centimeter long teeth can do some serious damage. Even with the hippo's poor eyesight, having a huge gape should get the point across. But just in case the visual threat is ignored, hippos send another warning. This time, scent is used in a rather unique way. Hippos have a great sense of smell, a fact not lost in domain disputes. As the hippo goes to the toilet, it vigorously wags its tail, spreading poop far and wide. Dung spraying is the hippo's way of marking its territory. Breeding males fling feces at the competition in hope that these smelly encounters will decide the winner without resorting to a fight. In the savanna of East Africa is another social species. Baboons live in troops of related females, offsprings of various ages, and several adult males. Each individual has a rank with a dominant in charge. They get the best resources first, including access to the ladies. But life at the top for the troop leader is not all fun and games. Every day, there are pretenders to the throne looking for mating rights. Young, virile males transfer from other groups to find a mate. These yawning threat postures send a strong visual message, exaggerating the length of the canines. But there are less aggressive ways of keeping your rank. Grooming is used to make friends and influence others. It's a communication tool that builds relationships and maintains strong bonds. This social sense of touch helps keep harmony in the group. A world away on a different continent, things are heating up on a California beach. These beach bums are northern elephant seals. It's late November, and the breeding season has started. Mature bulls have begun to arrive with one thing on their mind. The males will fight to determine who will be dominant. The winner's prize is a harem of blubber babes. Rather ungainly on land, these tubs of fat with pendulous noses can still pack a punch. In the elephant seal world, size does matter. The nose of a bull elephant seal starts to grow at puberty and continues to grow with age. It can reach 2 feet in length. Fights between males can get bloody and be surprisingly energetic. A testosterone-fueled fight has contenders rear up and slam their bodies against each other. The scars of past contests are clear to see on some bulls. But efforts are made to avoid armed combat. Throwing back their heads to show off their enormous proboscis, the message is clear, a visual signal to intimidate challengers. And the nose has another function to back up the menacing sight. It's a sound chamber to amplify bellows. The roar serves to identify individuals and assess their size. The bigger the nose, the bigger the bellow. The alpha male, also known as the beachmaster, roars his superiority. Mating season on the beach can be a noisy affair. Sight and sound are used to communicate dominance in the elephant seal's world. Thanks to the senses, conflicts are usually settled without a deadly conclusion. Another animal, where males flex their physical might to attract the opposite sex, lives down under. Twice the size of females, and with bulging biceps, males show off in the bushland gym. The gray kangaroo lives in semi-nomadic mobs. Ranging throughout Australia, they prefer open grassland with areas of bush for daytime shelter. At dawn and dusk, they come out to feed, grazing on a wide variety of grasses. Powerful back legs help them to travel at speeds of up to 65 kilometers per hour with minimal effort. During breeding season, males compete for females. Young bucks test their strength with each other by sparring. This ritualized fighting prepares them for adult life. In fact, the social life of a mob is akin to a barroom brawl, with constant pushing, grabbing, and shoving, even while feeding. This tactile behavior serves to communicate their status in the mob. But the real action is reserved for the adults. It starts off with an aggressive grass pulling, followed by the agitator rubbing their chests on the ground. Kangaroos have an excellent sense of smell. Spreading the testosterone-laced odor is a way to threaten their rivals. Scent marking is an important form of communication in marsupials. Studies have shown that social status could affect odor composition and act as a chemical fingerprint. Muscle-bound males enter wrestling and kickboxing contests. They lock arms and try to push each other over. The meter-long tail is used for support when the back legs are lifted off the ground to kick opponents. It is a dominant male that gets to mate the most. Physical displays matter in the kangaroo world, not just to intimidate opponents, but also to woo the ladies. Lounging males of breeding age have been found to strike a pose to show off their bulky biceps. It's thought to be an effective strategy. Research has shown that males with big muscles are sexually selected for. In other words, female kangaroos find the hunkiest males sexy. Koalas sleep. A lot. In fact, for 20 hours a day. That's all they do. Apart from the occasional itch that needs to be scratched, but even then, they don't wake up. Their strict diet of eucalyptus provides little nourishment and they need to conserve energy. A very slow metabolic rate allows koalas to digest their food over a long period of time to make sure as much nutrition is extracted as possible. Waking hours are spent chewing the fibrous leaves, and getting enough nutrients is even more important if you are eating for two. Joeys are born after 35 days of gestation. The tiny baby looks like a jelly bean at only 2 centimeters long. It's hairless, blind, and has no ears. But it makes its own way from the mother's birth canal to her pouch, relying on its well-developed sense of smell and touch to navigate to a teat. The joey stays with its mom for a year, during which mothers and babies make soft clicking noises and gentle humming sounds to one another. Sensory communication strengthens bonds between mother and young. A life of eating and sleeping sounds idyllic, and this tree hugger seems gentle, placid, and for all the world like a cuddly bear. But when the breeding season arrives in August, there's another much more active and noisy side to koala life. The koala's keen sense of hearing is put to good use in the eucalypt forest. Males issue sounds with a mixture of grunting, burping bellows. The noise is 20 times lower in pitch than the koala should be able to produce, a fact that has baffled researchers. But recent studies have found the answer. Koalas have 2 sets of vocal cords, unlike any other land mammal. The deep resonating calls of male koalas can penetrate far across the forest, advertising his social and physical position to females. Koalas are mostly solitary and avoid interactions where possible. Male koalas have home ranges that stretch over 4 acres. Some of these territories may overlap. A mature male has a gland on his chest that secretes a dark, sticky substance. He rubs the odor on trees in the overlapping areas. In this way, koalas use the sense of smell to communicate their presence to rival males by scent marking their boundaries. When it comes to mating rituals and courtship, birds can outdo mammals by sheer showmanship. The avian world has all manner of visual and vocal displays to attract attention and impress. Lyrebirds shake their tail feathers like a Las Vegas showgirl. Mannequins moonwalk like Michael Jackson. Prairie chickens use big boom bass that can be heard over a kilometer away. Brolga cranes jump, dance, and pirouette like prima ballerinas. And Magellanic penguins bill tap and flipper pat like Bavarian slap dancers. The sooty tern is another avian groover. Noisy and gregarious at breeding sites, they form large communities on rocky islands. The incessant calls of the colony have given the bird its name, wide awake. Unlike most terns, they don't dive, but pluck fish from surface waters. At the onset of the breeding season, sooty terns congregate in dense aerial swirls offshore, gradually getting closer to the nesting ground. Courting pairs engage in high flights. They ascend to great heights, then glide rapidly down to sea level. Once the terns settle on the ground, they begin to display. With thousands of pairs in close proximity, the honeymoon couple need to stand out from the crowd to get to know their new partner and form a bond. Prior to mating, both mates circle around each other with dropped wings and heads tilted. Sooty terns are monogamous, and this visual display serves to form a strong relationship, necessary to rear young over the coming weeks. Once the pair is formed and eggs are laid, both parents take turns incubating the eggs in shifts. When the chick hatches, foraging duties are also shared and sound sense plays a part. Adults call from the air as they come back to feed their chicks. The chick recognizes its parents' voices and calls back. They continue calling until the chick walks out to meet them, and the family share a fish supper. The satin bowerbird is not particularly flashy in the looks department. But it does have a unique way of getting attention. What it lacks in colorful plumage, it makes up for by kleptomania, stealing objects that it considers to be beautiful and worthy of display. This bird weaves a bower with thin twigs in an area to present its treasure for public viewing. The bowerbird is hoping to catch the eye of a passing female. It's particularly fond of blue objects. Different species have different color preferences, and researchers are trying to find out why. One theory is that bowerbirds choose the pigment that best complements their own coloring. The hard-working house husband spends a great deal of time arranging and rearranging his collection. He's meticulous at maintaining his design. When a big bird, like a brush turkey, comes wandering in, trampling his interior decorating, the poor male has to start again. But finally, it seems a female has taken interest. She inspects the bower and its contents. The bower and the blue treasure are only an enticement to step into the male's bachelor pad. The next stage of the courtship is the dance. The male leaps into action with a ritualized display of strutting and quivering, all the while carrying one of the bower decorations in his bill. To add to the assault on the female's visual senses, the male accompanies his routine with a variety of mechanical sounding calls. If impressed, the female stays in the love shack for mating. Then she will leave to begin nesting duties on her own, while the male readies himself for courting new girlfriends. Communicating accurate information is important if you want to get the girl. But there are animals that send out messages which are far from the truth. Some predators deceive their prey to make capture easier. The alligator snapping turtle sits on the bottom of a pond waiting. He eats gambusia fish, which feed on mosquito larvae. Weighing up to 90 kilos, this reptile is one of the largest freshwater turtles in the world. The secretive sluggish creature spends most of the daylight hours hiding. Moving fast isn't in his repertoire. The turtle doesn't seem capable of catching swift-moving fish like the gambusia, but it has a cunning strategy. It lies in wait with jaws wide open. On the bottom of the mouth is a worm-like lure, which it wriggles to entice unwary prey. The powerful, sharp-edged jaws are capable of severing a finger, and the fish stands little chance of escaping. This is predator-to-prey communication, and visual trickery is the name of the game. But the title of Master Trickster should go to this creature. Dangerous and cunning, the Portia spider is a master of deception. Portias are a genus of jumping spider. Its favored food is other arachnids, like this one, a green water spider called a hygropoda, which produces mat-like webs on leaf surfaces. The non-sticky silk doesn't snag prey as such. The web serves more as an arena for the fast-acting hunter to capture its dinner. The slightest movement is a critical attack cue. With stabbing fangs, hygropoda is a lethal adversary for a predator. But the jumping spider is not deterred. Using a remarkable hunting tactic, it exploits the water spider's sensitive detectors. The hunter slowly approaches the web of its prey. Moving its legs along the web, the Portia plucks the silken strands as it goes. It's not just testing for movement, but delicately strumming the threads to arouse the web owner's curiosity. With stealth as a weapon, the jumping spider is mimicking its victim's prey. This unique cryptic stalking is a remarkable strategy. But that's not all. Portia spiders are astounding scientists with their range of hunting behaviors. Their strategies alter depending on the species of prey in question. These redback spiderlings are defenseless against the Portia's cunning. They can improvise their tactics in unfamiliar situations and remember the technique. Researchers don't understand how a creature with such a small brain can seem so intelligent. But what is plain to see is the Portia spider uses the sense of touch to deceive its prey. The senses are the stars on animal supersenses. In this show, we found they are vital to animal communication. Visual displays depend on sight. Vocal performances rely on hearing. And scent trails trust in the sense of smell to deliver a message. Without senses, animals couldn't communicate. They would be isolated and struggle to survive. Senses truly are sensational, as we've seen. Find out more amazing powers of animal perception next time on Animal Super Senses.
Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears. The antennae of a butterfly, which up close look like feathers. The snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal super senses. You won't believe what's possible.
Animal Super Senses has taken us on an extraordinary tour of the sensory world of animals, showing us how many species have remarkable powers of perception. And every sense is employed to survive in a hostile world. The bear, with a sense of smell 7 times better than a bloodhound. The chameleon, with 360-degree vision. The elephant, hearing infrasound. With super senses like these, human abilities are pretty poor in comparison. In this episode, we revisit the most amazing super senses of animals. To become the supreme predator of the African savanna, the lion uses sniper sight as a tool to kill. During daylight hours, their eyesight is said to be about level with ours. But at night, they shift gears. Lions are believed to see 8 times better than we do in the dark. A lion's eye is designed to pick up the faintest light. When night falls, the available light comes from the moon and stars. It makes the lion a formidable killer after dark. The clue to the lion's superior night vision lies inside the eye. The retina is covered in tightly packed light-sensitive cells, many more than humans have. But that's not all. They have what is known as tapetum, a reflective layer of cells at the back of the eye. It's what we see when we point a flashlight into the dark, and eerie eyes shine back. The tapetum reflects visible light back through the eye, giving the photoreceptors a second chance to absorb light rays. Thanks to the lion's super sense vision, they can hunt in the cool of the evening and save energy during the daytime heat. The lion has become the master of all its surveys. Another of Africa's big five, the elephant. This giant shares the savanna with the lion. Both are social animals. The African elephant lives in family groups of closely related females and young, led by a matriarch. Males wander on their own. When you live in the savanna, having the power to communicate over distance is important. It maintains family bonds and detects outsiders. It sends out a message broadcasting who you are, where you are, and if you are friend or foe. But it's a world that humans can't hear. Most of the sounds that elephants make are transmitted at lower frequencies known as infrasound, below the level of human hearing. These low frequencies travel great distances. As a result, elephants can eavesdrop over a huge area. They are known to make more long-distance calls after hours, namely at dusk when it's cooler and sound can travel further. It seems that the elephant's senses are perfectly adapted to its environment and essential for its survival. A female needs to signal to wandering males that she is ready to mate, but a breeding bull could be many kilometers away. Sending out a mating call that can extend over a savanna-sized range improves her chances of finding the biggest and strongest male. And it's the trunk call that no bull elephant wants to miss. Sight and sound are good for long-distance perception. But if you want to get up close and personal, the sense of touch is going to be your best bet. Touch plays an important role in the life of a kangaroo mob. Mutual grooming is a practical way for this social animal to form close bonds. And there are few bonds in the wild stronger than a mother kangaroo and her baby Joey. Young roos test their strength with peers by pushing, grabbing, and shoving each other. But the real action is reserved for the adults when touch becomes territorial. And muscle-bound males show off in a bushland gym. A tactile toolkit matters in the kangaroo world, as the winning wrestler gets to mate the most. One of the greatest noses on Earth belongs to this creature. perhaps no other animal has a keener sense of smell. Smell helps the bear to find food. They can detect a meal several kilometers away. The sense of smell also plays an important role in bear communication, helping them to locate mates and to recognize their young. Even though a bear's brain is only about a third the size of a human's, the area of its brain which manages smell is at least 5 times larger. The surface area inside their noses is thought to be 100 times greater than a human's. Making their sense of smell 7 times better than a bloodhound's. It can easily smell traces of food left on clothes and in tents. So, if you're camping out and there's a sniffing sound, you may have a bear at your picnic. Some animals seem to have superhuman senses. Take, for example, the monarch butterfly, with its superior sense of direction. They spend their summer months in the eastern part of North America, before flying south to a single mountainous spot in Mexico. A journey of up to 5,000 kilometers. How do they navigate their way? It's a question that's intrigued scientists for years. Now, experts think they know the answer. The monarch butterfly detects the Earth's magnetic field. An internal compass, located in the antennae, contains light-dependent magnetosensors. The butterflies that have flown south enter a period of inactivity as they overwinter in Mexico. The warm, lengthening days of March signal them to be active again. They become ready to mate and lay eggs as they move northward. Their eggs mark the start of another annual life cycle. And a new generation uses the internal compass to make its epic journey north for the spring. The monarch's phenomenal abilities in the air may be matched by the shark's prowess underwater. Animals seem to sense changes in the environment that completely escape human perception. In 2001, a team of researchers had been tracking the movements of a population of black-tipped sharks off the coast of Florida. The sharks were residents in the bay for 6 to 8 months during the summer and didn't leave the area until migration time, and definitely not in large numbers. Tropical storm Gabrielle made landfall in central Florida during their research. When the team returned to check their equipment, they reviewed the movements of the tagged sharks to find an amazing result. Not only did all the tagged sharks leave, but they had left some 7 hours before the tropical storm hit the coast. Scientists examined the data to try to find out what on earth was going on. They found the sharks swam to deeper waters, just around the time when the air pressure started to drop prior to the storm's approach. It seems the sharks responded to the decrease in pressure and got out of town before the storm hit. Animals that live life on the wing have to make the most of what the aerial realm has to offer. Given the vast openness of the sky, their senses have adapted to cope. Being small doesn't matter. The dainty dragonfly is one of the most brutal and effective predators in the animal kingdom, thanks to its superior sight. They have multifaceted or compound eyes, and along with bees, have the largest eyes of any insect. They see the world in a mosaic. But that's not all. Dragonflies have 5 opsins, or light-sensitive proteins. Humans only have 3, for seeing red, green, and blue light. This allows dragonflies to see colors beyond human abilities. And it's these opsins' unique placement in the eye of the dragonfly that helps them to hunt. The upward-facing part of the compound eye only has blue and UV receptors. It may help hunting dragonflies as the sky appears to be very bright, giving a clear background against which small, fast-moving prey can be more easily detected. Dragonflies have fighter-pilot control and rarely miss their target. They can fly backwards, change direction in midair, and hover for up to a minute. Because of this, their prey stands little chance. And it's their super sense eyes that make the dragonfly a formidable aerial hunter. Another aerial predator uses a revolutionary technique to catch its dinner. They also have to grab small, quick-moving insects during flight, but they have an additional challenge. They have to find their food in the dark. Microbats spend their day in roost sites. This is where they mate, raise their young, and socialize. During the summer, females gather together in their hundreds in what is known as a maternity roost, where they give birth to a single baby called a pup. For around 4 weeks, the baby bats are fed solely on their mother's milk, until they are old enough to fly. This period costs a lot in terms of energy for the mother. So they enter a state of torpor during the day to reduce their body temperature and metabolic rate. At sunset, they emerge from their roost to pursue insects and stock up on lost energy. A bat can consume up to 3,000 insects in one night. Their success in aerial hunting is thanks to a special supersense, echolocation. Instead of using their eyes, microbats see with sound. They fire sound waves out into the darkness and listen to the echoes that bounce back. Using echolocation, the bat can determine where the insect is, how far away it is, and what direction it is moving. It's a technique humans have used to develop sonar navigation systems in the military, using large equipment and expensive technology. The little bat, of course, just does what comes naturally. Thanks to echolocation, living the night shift doesn't stop this bat using its sense to survive. Finding food hidden underground has similar challenges to hunting prey in the dark. In both cases, the sense of sight is tested to its limit, and other sensory tools are needed. The short-beaked echidna has a specialized diet. It only eats ants and termites hidden deep in the earth. It uses its powerful, stout limbs to dig into soil and rip open rotting wood. But it's the echidna's nose that is key to its success. Echidnas can detect prey by smell, but they also have a unique sense found only in a handful of animals on the planet. With the tip of its snout, they are thought to sense electricity. Until recently, the platypus and echidna were the only mammals known to use this electroreception. The structures responsible for this electric sense in echidnas are sensory mucus glands. It's not fully understood how they use these, but tests have shown they can detect weak electric fields in water. As water is a good conductor of electricity, echidnas may be able to detect moving prey in moist soil. Sensing changes in the environment is vitally important to animals. Their lives depend on it. If winter is coming, they have to adapt. Some animals register seasonal change by refashioning their winter wardrobes. During the short polar summer, the Arctic fox's fur is brown. But as winter sets in, the fur becomes thicker and turns white. But exactly what is at work to help animals keep in sync with the seasons? Deep inside the brain of many animals is the pineal gland. It produces the hormone melatonin. The pineal gland can measure the length of day versus night. It receives this information via the eyes. Melatonin levels are low during daylight and increase to a peak at dark. As winter approaches, the hours of daylight shorten and melatonin increases. The hormonal surge cues the Arctic fox's sense of timing to change its coat color. In Animal Supersenses, we've seen how the sensory world of animals is astonishing, varied, and in many cases, superior to that of human abilities. Senses are vital to animals. Without them, they would be cut off from the world, unable to see, smell, hear, taste, and touch their environment. Animals' supersenses are their key to survival.